my construction of a perpendicular bisector of a given segment. So I'm going to grab a circle here. Oh, no, that's not going to work. Okay. So what I'll do is I'll try and make it as accurate as I can, but basically what you want to do is you want to open up your compass so it's more than halfway to B from A, and you draw that first arc. So I'm going to try and like really do this accurately. So this is more than halfway to B, and I draw this first arc, trying to keep the distance from A and these ticks the same amount. See if I can do a good job at this. So basically this is your first arc that you're drawing, and obviously from A to the arc is always the same, and you keep the compass at the same setting and you do the same thing but now from B. So you go and then you sort of draw these ticks down, right? And you have this here. There's something that's going to look like this. And what you should see is that they're going to intersect at these 2 points. Let's call these 2 points P and M. Okay, and again, what we need to really just convince ourselves of is that the distance from A to P is the same length as from B to P. And the distance from B to M is the same length from A to M. Okay, which means that P is equidistant from the endpoints, and M is equidistant from the endpoints. Therefore, P and M both lie on the perpendicular bisector. And then that means that the line joining P and M is the perpendicular bisector. So you draw that line, PM, and this line, PM, is the perpendicular bisector. Now I'm just going to prove it real quick. So I have my statements and reasons chart, let's say. So statements and reasons. And basically I'm going to write as statement 1, I'm going to write that by my construction, right, AP is congruent to BP. And AM is congruent to BM. And that's by my construction. Okay, now 2. 2 is going to be that once you have that this is congruent to this, then what is that saying about P? P is equidistant from the endpoints. By the perpendicular bisector theorem, if P is equidistant from the endpoints, then P lies on the perpendicular bisector. P lies on perpendicular bisector. And you also have that M is equidistant from A as it is from B. So M lies on the perpendicular bisector, and you could say of segment AB. And M lies on perpendicular bisector of AB. And that's for the same reason. So that's perpendicular bisector theorem. Perpendicular bisector theorem. Three. Okay. Now that you know that both of these, P and M, both lie on the perpendicular bisector, you can just simply state PM, what you drew, your constructed line PM, is perpendicular bisector of AB. And the way you could say that is that 2 points define a line, and that there's only one perpendicular bisector of a segment. But you could just say 2 points define a line. And perpendicular bisector is, of course, a line. I have 2 points on that line, and the line joining them must be the perpendicular bisector. And you could even just put, right, saying that it's all right angles and that this is congruent to this. Right, or at this point, I don't know what you want to call it. Okay, who cares? Doesn't matter. You don't need to write that. But yeah, then this is you construct this here and you prove it right here. You're good.